Hi and welcome to Quick Add Math on series. I wish to begin with the Pascal's triangle. Its row 0 has the number 1, and each number from row 1 and onwards is the sum of its top left and right numerals. Horizontally, it mirrors the coefficients of x plus y all to the power of n, where n is equal to row. Diagonally, it also generates the patterns consisting of natural numbers, triangular numbers, tetrahedral numbers, and pentalope numbers. With this knowledge, we can make quick work on expanding x plus y to the power of 3 into x cubed plus 3x squared y plus 3xy squared plus y cubed, and so on. Let's put this to the test under tutorial question 1, where we asked to expand 2x minus 5 to the power of 4 leveraging Pascal's triangle. This is simply the numbers on row 4 of Pascal's triangle together with 2x in decrements from its order of 4 and minus 5 in increments to its order of 4, which is quicker work than multiplying 2x minus 5 against itself 3 other times. Tutorial question 2. Find the coefficient of x for the product of 1 plus 2x and 1 plus 3x all to the power of 4. Again, we shall leverage on the numbers on row 4 of the Pascal's triangle, with particular interest on the coefficients pertaining to x and x to the power of 0, as these would need to be multiplied against 1 plus 2x to obtain the total required coefficients for x. This comes to 14. Tutorial question 3. Expand 2 minus x squared with the order of 4 and find the coefficient of x to the power of 6 in the product of 1 plus 3x squared and 2 minus x squared with the order of 4. Again, we'll leverage on the Pascal triangle to expand on 2 minus x squared with the order of 4, with particular interest on the coefficients of its x to the power of 4 and x to the power of 6, as these would multiply against 1 plus 3x squared to obtain the required total coefficient of its x to the power of 6, which comes to 64. Next, mathematicians have noted there is similarity in NCR against the numbers in Pascal's triangle, allowing the expansion of x plus y with the order n to be stated with the combination notation. Let's try this on tutorial question 4, where we are asked to find the coefficient of x to the power of 20 of x plus 2 with the order of 25. This would be the product of the combination notation 25C5 and 2 to the power 5, which works out to be 1,700,160. In an arithmetic progression, each number in succession maintains a common difference. For example, 1, 7, 13, 19, 25, and so on has a common difference equal to 6, with the first number being labeled A and the common difference being labeled D. It will create the sequence of A plus D, A plus 2D, A plus 3D, A plus 4D, and so on, which can be formularized for its nth term as A plus the product of n minus 1 and D, by further labeling its last number as being L, the sum of all n numbers in its finite sequence. Sn is the product of n and the average of A plus L, which in turn is also equal to the product of n over 2 with 2A plus the product of n minus 1 with D. Tutorial question 5. Find the number of terms and the sum of the series 23 plus 27 plus 31 plus all the way to 159. Here we will leverage on the formula A plus the product of n minus 1 and D being equal to 159 to find its nth term. Then applying this nth term onto the formula of Sn. Tutorial question 6. An arithmetic sequence has its first term equal to minus 13, its 20th term equal to 82, and its last term equal to 112. Find its common difference. Again, this would be leveraging on A plus the product of n minus 1 with D being equal to 82 to identify its D. Next, find its number of terms. In this case, you would again apply the formula of A plus the product of n minus 1 with D being equal to the last number, which is 112, to identify its nth term. Next, find the sum of the numbers for the entire sequence. This would be placing n as 26 into the Sn formula. Tutorial question 7. The sum of the first n terms Sn of a particular arithmetic progression is given by Sn being the product of n over 12 and for n plus 5. Find an expression for its nth term. For questions of this kind, you start by identifying its S1 and S2 values, then subtract S1 from S2 to obtain its second term. From here onwards, you can identify the difference between its first and second term to obtain its D. Its nth term can be identified using the standard formula of A plus the product of n minus 1 with D for it to arrive at it being the product of 112 and 8n plus 1. Next, in a geometric progression, each number in succession maintains a common ratio. For example, 1, 1.5, 2.25, 3.375, 5.0625, and so on has a common ratio equal to 1.5. With its first number being labeled A and its common ratio being labeled R, it will create the sequence A, AR, AR squared, AR cubed, AR to the power 4, and so on, which can be formularized for its nth term as AR to the power of n minus 1. And in a geometric progression, its Sn is equal to the product of A with R to the power of n minus 1, all being divided by R minus 1. Tutorial question 8. Three consecutive terms of a geometric progression are x, x plus 6, and x plus 9. Find the value of x. Being a geometric sequence, the ratio of its second term against its first term is the same as its third term against its second term, allowing us to solve for x. Tutorial question 9. In the geometric sequence 0.25, 0.5, 1, 2, 4, which is the first term to exceed 500,000? With its nth term being the product of A and R to the power of n minus 1, we could equate this as being larger than 500,000 and solve for n. Next, an infinite series has terms that continue endlessly. And in an infinite geometric series, its Sn can be simplified as just a over 1 minus r. Tutorial question 10. Find the sum to infinity for the geometric sequence 3, 1, a third, a 9, and so on. This would put a as being 3, r as being a third, and we could apply its formula of Sn being equal to a over 1 minus r to get to the solution. Tutorial question 11. Write the recurring decimal 0.42 as a geometric progression and show that it can be written as 14 over 33. By writing its recurring decimal of 0.42 as being 0.42 plus 0.0042 plus 0.000042 and so on, where this is a equals 0.42 and r equal 0.01 in a geometric progression, we could solve for its sum as being 14 over 33. That's all for Quick Add Maths on series. If you found this useful, do look out for other videos under the KT Tutorial channel.